In this episode, we're going to look at how to configure and modify standard IPv4 access controllers. I'll show you how to do it, and we'll talk about the concepts along the way. Network security and traffic flow control are important issues when designing and managing IP networks. The ability to configure proper rules to filter packets based on established security policies is a valuable skill. We'll set up filtering rules for 2 business locations that are represented by a couple of routers. Management has established some access policies between the LANs, which we must implement. The edge router sitting between our 2 routers has been provided by our ISP and will not have any access controls placed on it. We are not allowed any administrative access to that edge router because we can only control and manage the equipment we own. We'll be discussing how to verify connectivity, configure and verify standard numbered and named access control lists, and then how to modify a standard access control list. Greetings to my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 5.2.7, configure and modify standard IPv4 access control list. The packet tracer file opened up. On the left side, I have our work area. I have our topology. This is where we're going to go in and do our configuration of our access control list. On the right side, I have our instructions. On the very bottom right is the actual packet tracer activity window that opens up with the instructions. The main part on the upper right, that's a Word document of those same instructions. The reason I have the Word document is we got some questions to answer. The Word document will allow me to enter my answers in and save them. Here for our network, we got 3 routers, a couple networks coming off of the bottom 2 routers, and then a connection to the internet. We have our addressing table here. Here in our addressing table, we have all of our devices. We have their interfaces, their configured IP addresses. So we're going to come back here and refer to this a couple of times. On to our instructions. Part 1. In part 1, we're going to verify connectivity. Very important to test whether connectivity is working before you configure and apply access lists. You want to be sure that your network is properly functioned before you start. So we want to make sure that everything is working, and then we're going to filter back our traffic. First thing we're going to do, from PCA, ping PCC and PCD. So PCA, I'm going to go ahead and click on PCA, slide it over, click on the desktop tab, click on the command prompt. I'm going to scroll up to look at our addressing table. So I'm from PCA, I'm going to ping PCC 192.168.30.3. So go ahead and type in ping 192.168.30.3. Hopefully we're doing an ARP lookup here. That's going to fail. There we go. First one failed. Next 3 worked. To verify it, what I'm going to do is hit the up arrow to repeat the command and hit enter. All 4 pings are going to work. They're all working. Shows that we have connectivity. Next thing would be to ping PCD. Ping, and then the IP address for PCD right here, 192.168.40.3. 192.168.40.3. Probably have to do an ARP lookup, which will time out the first ping. And then the next 3 will work. I'm going to go ahead and repeat that command one more time. Up arrow, hit enter. And we have 4 complete pings. Back down to our question. Were they successful? Yes, they were, from PCA to PCC and D. Next question, from R1. So R1 is right here. We're going to ping PCC and PCD down here and to see if we have connectivity. So I'm going to click on R1, bring this up, click on the CLI tab, and then I make this window a little bit bigger, going right to left, just so it lays out a little bit nicer. Hit enter. You can type enable to get into privilege exec mode, and then we can ping our PC3. That IP address once again was 192.168.30.3. or we're pinging PCC, sorry, not PC3. And then now we're going to ping PCD, PING space 192.168.40.3, IP address of PCD. All 5 of those works. We have exclamation marks here. You can see we got a set of 5 up here when we ping PCC. We got 5 exclamation marks when we ping PCD. The exclamation mark in the Cisco iOS means it worked. So we have a success rate of 100% for both of them. Did our pings work from R1 to C and D? Yes, they did. From PCC, let's ping PCA and PCB. I'm going to minimize R1 window, click on PCC. PCC, I'm going to click on the desktop tab, click on command prompt window. I'm going to go ahead and type ping. And then the IP address for PCA. Here's the IP address for PCA, 192.168.10.3. 192.168.10.3. Looks like all 4 of those pings are going to work. And let's go ahead and ping PCB. PCB's IP address is 192.168.20.3. 192.168.20.3. Might have to do an ARP lookup, which will time out the first ping. But the next 3 will work. I'm going to repeat that command just to make sure all 4 will work. And there it is, all 4 work. So PCC was able to ping PCA and B. Were they successful? Yes, they were. If you notice how those IP addresses laid out, all the PCs, the last octet was a .3. And then this network over here, the third octet is a .10. So PCA's address is .10.30, third octet, fourth octet. This is the .20 subnet, the second one. So PCB's IP address is 20.3. This is the third network, or the .30 in the third octet. So that's 192.168.30, and then .3 for the PC. So .30.3 is the PC address of PCC. And PCD, this network here is the fourth one. It's .40 in the third octet, and so it would be .40.3 here for the IP address on PCD, just so you can help understand those IP addresses. From R3, ping PCA and PCB. So here's R3. We're going to go ahead and ping PCA and PCB. Click on R3. Click on the CLI tab. Make the window a little bit bigger. Hit enter, log in, type in enable to get us into privileged exec mode. Then we're going to ping PCA. So ping 192.168.10 because it's on the first network. And then each PC's last octet is .3. We have 5 successes, 5 exclamation marks. That has worked successfully. Now we're going to ping PCB. So ping 192.168.20.3. Those work successfully. So those 3 have worked successfully. Can R3 ping A and B? Yes, they can. Now, can all PCs ping the server at 209.165.200.254? I'm going to minimize R3. Here is the server. It's like a web server across the internet. And can all 4 of these PCs ping that server? I'm going to go into PCA, type in ping, and then the IP address of 209.165.200.254. Might have to do an ARP lookup, which might time out the first ping. So that it looks like that's what's happening. I'm going to repeat the command, up arrow, enter. All 4 pings should work. So PCA can ping the server. Let's try PCB. On the desktop tab in the command prompt app, go ahead and type in ping 209.165.200.254. All 4 pings work from PCB to the server. That works. Let's go ahead and look at PCC. Ping 209.165.200.254. From PCC to the server, all 4 pings have worked. And finally, from PCD on the desktop tab in the command prompt app, You can go ahead and type in ping 209.165.200.254. And all 4 of those pings have worked. So all 4 PCs can ping the server. So we have full connectivity in our network. Oh, got to answer the question. The answer to the question is yes. PCs can ping. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part 2, configure and verify a standard numbered and named ACL. We're dealing with standard ACLs. Standard ACLs filter traffic based on the source IP address only. So where did this packet come from? We're going to look at that layer 3 IP address on where it came from, and that's all we're going to use to filter. Typical best practice is for the standard ACL to be configured and applied as the closest to the destination as possible. So there's a start and a finish. You want to apply that standard ACL as close to the finish as possible. So that closest router is where you want to apply that. For the first access list in this activity, create a standard numbered ACL that allows traffic from the 192.168.10 network. So from this network right here, the bottom left one, and all hosts from the 192.168.20 network, that's the second network right here. So all the hosts on these 2 networks, the .10 and .30 networks, to access the hosts on the .30, I think I just said that wrong, the .10 and .20 networks to access, and here's the .30 network to access the hosts on the .30. So we have to allow these 2 networks, .10, .20, to get onto this network. The security policy also states that an explicit deny any access control entry, so we have to put a deny any at the end. Even though there's the implicit deny at the end of your access control list, you don't have to type that in. We want to explicitly put one in there. Now that's to make sure that it actually does do that, because we just want to doubly make sure. You have a corporate policy that says you need to do it. Plus, when you explicitly type that deny any in there, it will keep track of the number of times that was matched and that was applied, that we denied something. So you can get an idea of how many times a device is being denied access to that network. On to the question. What wildcard mask would you allow all hosts on the 192.168.10/24 network to access the .30 network? So they're looking for the wildcard mask. We can figure out the wildcard mask from our subnet mask. So right here's our network address, 192.168.10.0, and then we have a /24. /24 means in our subnet mask, which once again is different than the wildcard mask, in our subnet mask we have 24 ones followed by 8 zeros, or 255.255.255.0 if we turn it into dotted decimal notation. Wildcard mask, you invert the ones and the zeros from the subnet mask. So we got 255, 255, 255 zeros, 24 ones followed by 8 zeros. We now invert that. And so ones turn to 0, zeros turn to 1, and that 24 ones to start with now turn into 24 zeros. Those ending 8 zeros in the subnet mask now turn into 8 ones in the wildcard mask. So we got 24 zeros followed by 8 ones, turn that into dotted decimal notation. We have 0.0.0.255. And so that would be our wildcard mask we would use, 0.0.0.255. Following Cisco's recommended best practices, on which router would you place this? And so we are allowing traffic from these 2 networks to get onto this network. And so this is the destination network. You want to apply it to the router that is closest to this network. The router that's closest to this network happens to be R3, the one that's actually directly connected to that .30 network. So we want to apply it to the R3 router. Next question. On which interface would you place the ACL? In what direction would you apply it? Now, we're applying that ACL, that access control list, close to the destination as possible. So that's on R3. If we apply it on this interface right here, we're actually going to filter all traffic coming into it. There may be legitimate traffic that needs to go down to this .40 network. So PCA or PCB may legitimately need to go down to this network. So we don't want to block that. Putting it up here would block everything. Yes, it would block the .30 network, which we want to do, but it might also block the .40 network. If we put it down here on this interface would block traffic coming down to the .40, but still allow it to go to the .30. That's just not what we're trying to do. If we put it on this interface right here, put it on this interface that's going down to that .30 network. If we put it on this interface, all the traffic can come into R3. If it needs to go to R4, it'll go through because it's on the interface that isn't connected to that network. And we're applying it to the traffic that's going to this network. So it needs to go onto this interface. Now, how do I figure out what interface that is? I'm going to click in this window right here. I'm going to click on a white space to make sure this window is activated. Then I'm going to mouse over that green triangle that's close to the R3 on our network. And then it's going to pop up and tell me what interface. So it needs to go on the gig 000 interface. And then which way do we need to apply it? Well, we're filtering traffic as it's going onto this network. So it's going out of this router, out of this interface onto the .30 network. So it's going to go to outbound traffic. So on which interface would you apply it? Gig 000. And in what direction? We would go to outbound traffic. So going out is where we would apply that. Okay, let's go ahead and enter that in. So let's go ahead and configure that ACL on there. So on R3, we're going to go in here. And when we set up this ACL, this access control list, we do this in global configuration mode. So we got to go ahead and type config T. And then we start off with saying access list. Access-list. And then we were told, or we're going to use number 1. We're going to use number 1 as our access list. And then first thing we're going to do is start off with a remark. So start off with a remark. Instead of permitting or denying, we're just going to put a remark in there to remind us in 3 months, 6 months when we come back, what was this access list supposed to do? So we're going to put in a remark. One thing to know, it doesn't matter how you type this in a production environment, but here in Packet Tracer, it is case sensitive. That remark is case sensitive, so it needs to match and it needs to be exactly as they have it in the instructions. So it needs to look exactly like this. So I'm going to go ahead and type that in. Capital A, allow R1 lands. Notice it's capital L, capital A, capital N, lowercase s, and then capital A access. So we have access list, and then which access are we putting it on? This is a remark, and then what we're putting here. So allow R1 lands access. I'm just confirming I typed that in right, because once again, I said it's case sensitive here in this packet tracer. Make sure you have it exactly right. Next one, let's go ahead and add in some more. We're going to permit that the traffic from that .10 network. So we start off once again with access-list going on list 1. And here we are permitting. So we type in permit and then that network address 192.168.10.0 and then the wildcard mask. That wildcard mask once again was 0.0.0.255. Then we have to permit the second network. So access-list. We're doing access list 1. I gotta go spell access correctly. So access list 1. We're going to permit that second network, that .20 network. So 192.168.20.0. And the wildcard once again was 0.0.0.255. 3 zeros and a 255. And then we have to put our explicit deny in there. And so we're going to add that right into that same access list one. So it's access dash list one. And then we're going to deny. Now we want to deny all the traffic that makes it down to it. If it doesn't make that first permit access control entry, doesn't make the second one, so it wasn't permitted to go through, it's going to make it down to this one. And we just want to deny anything that goes through there. We could enter 2 quad zeros. So 4 zeros followed by 4 zeros. The network portion is 4 zeros, and there's zeros there, and then there's zeros in the wildcard mask, meaning we're going to take everything that you send us that makes it down to here, and we're just going to deny it. Or we could just simply type in the word any. So we're going to deny any. Deny anything that makes it here. This sets up our access control list. We have our access control list here. Now we have to go and set it on an interface. We have to activate it on an interface. We figured out that we're going to do here, we're going to do gig 001 and for outbound traffic. And so we have to go into that interface. So it's interface gig 000. And now we're going to go ahead and say what access list we're doing and then what direction. IP, because we're part of the IP suite, and then it's access group is the word we put in here. It's, and how I remember that is it's a group of access control entries that we're going to put in here. It should really say access list, but here we have access group. It's a group of rules that we're going to apply to this interface, a group of access control entries. So IP access, and then we put in the number of the group. We've set up our access list as number 1, so we're going to put 1 in there for access list 1, and then we say what direction, and we want to apply the traffic going out of that router, out of that interface, onto that .30 network. And so we can go ahead and type out. That applies access list 1 to any outbound traffic going out that gig 000 interface. Verify a numbered ACL. Use various show commands to help you identify and verify both the syntax and placement of your ACLs. To see access list 1 in its entirety with all ACEs, which command would you use? Well, here in R3, we can use the show access list command. Now, I'm going to go ahead and type out exit here once, exit twice, bring us back into privileged exec mode, and the command show access dash list will list out all of the access lists we have configured. Right now we only have one numbered standard access list. It lists out, so it says we have a standard access list on the IP protocol, and it's list 1. And then it lists out our access control entries. It doesn't list out the remarks. It actually lists out the permits and the denies. That's all this will list out here. And so we can verify it. Here we're letting the .10 network through. Here we're permitting the .20 network through. And if something doesn't match these first 2 lines, it makes it down to this, and it's the deny any. And so the command here we could use is show access lists. Be warned here, autocorrect here made it a capital letter. It should be a lowercase s on show. And of course I need to spell access right. If you have a bunch of access lists, you don't necessarily want to go through all of them. You can narrow it down. So instead of just doing show access list, what we could do is show access list, and then we can say what number do we want to specifically look at. We could put a number 1 there, and it will just give us access list 1. We only have 1 right now, but you could filter it out that way. And so, or else we could do a show access list and then put the name or number of that access list in there. Next question, what command would you use to see where the access list was applied and in what direction? Once again, remember, we're applying it to the interface, so let's look at the interface. Here on R3, let's go ahead and do a show IP interface, and then once again, that was on G000. Looking here, You can see here's gig 00, gives us the status information. We're up. We have an IP address, and then a couple lines down, we have outgoing access list is 1. So it's telling us any outbound traffic is going to get access list 1 applied to it. And then any inbound traffic on gig 00, there is no access list. So we're not going to do any filtering. It's just the outbound traffic is going. The show IP interface command does that. Okay, so show IP interface command does it. You could enter in the show IP interface command. I'm going to go ahead and do that. Show IP interface, and look at here we have gig 000. If I hit the space bar, it takes us to gig 001. Then it takes us to a serial connection, another serial. It takes us through all of our interfaces. But if I actually put in the show IP interface gig 000, it'll just give me gig 00's worth of information. So we could put in the show IP interface, or we could put in show IP interface and then actually say what interface we are looking at. And once again, Word auto capitalized it should be lowercase. On R3, issue the show access list 1 command. We look back here, that's what we entered, but let's go ahead and just do that one more time. Nice to reinforce. So show access list 1. Here's our access list. Once again, 2 permits and an explicit deny any. Then on R3, let's go ahead and issue the show IP interface G00 command. Show IP interface and then gig 000. Once again, here's the status information for our gig 00, IP address of that interface, and right here is our access control list information. Outbound traffic gets access list 1. Inbound traffic on gig 00 does not have an access list. On to number 3, test the ACL to see if it allows traffic from 192.168.10 network to access the .30 network. From PCA, command prompt ping PCC address. So I'm going to go ahead, open up PCA, click in the window, and type in ping 192.168. So we're on A, we're going to ping PCC. That was on the .30 network, the third one over, ABC 102030. And all PCs have a .3 in the 4th octet, so we can go 192.168.30.3, and it allows it through. We have an ACL. Once again, we have an ACL right here that is permitting traffic from the .10 and .20 network to go through. So did that work? Were the pings successful? Yes, they were. 4. Test the ACL, see if it allows traffic from the .20 network to access the .30 network. So .20 network right here, can it access .30? Well, that ACL, we're going to permit it from this network, so that should work. I'm going to open up PCB, and I'm going to go ahead and ping PCC 192.168.30.3. And the ACL allows the pings to go through. So yes, we were able to ping. 5. Should pings from PCD and to PCC be successful? Ping D to C to verify your answer. Should they be successful? Now, the access control list is permitting traffic only from the .20 and .10 and .20 network. That's the only traffic allowed through. PCD is on the .40 network. It's on a different network. It's not on an allowed one. It should get blocked by the ACL right here. So no, it should not be able to. No, and it's because it is not on an allowed network. Let's go ahead and test that baby out. Open up PCD here. and I'm going to go ahead and ping PCC 192.168.3. I'm sorry, .30. I'm going to start that address over. I'm having problems typing right now. 192.168.30.3. And now it's saying destination unreachable. So we're on PCC. We're on PCD. We're pinging PCC. And it's coming back and saying that this address, 192.168.40.1, which is the default gateway for the .40 network. So it's this address right here, which is essentially R3. So R3 is saying destination of the host is unreachable. Why is it unreachable? We're only allowing traffic from the 20 and 30 network through there. This is on the .40, so we're not allowing that. Another interesting point, so the R3 was saying destination was unreachable. Another interesting point, if you look at our ping stats, we sent 4, we didn't receive 4. Now, depending upon your version of the command prompt you're using, it may show you've got 100 successes back. You sent out a ping request, you got a reply. But that reply said, I couldn't reach my destination, so technically it didn't work. So make sure you look at your ping statements and see, just because it says it's successful, if you were on a true operating system, it most likely would say it was 100% successful, but you would still get the destination host unreachable. So make sure you read what's going on in your ping statements. So we just tested out 5 here. Onto D. From the R1 prompt, from router 1 prompt, ping PCC's address again. Okay, so from R1, we're going to go ahead and ping PCC. And once again, R1 is right here. Now, it's not traffic that's going to originate on either one of these two networks. It's going to appear that it started on this network right here. Because it started on this network, it's not on one of the allowed networks. It shouldn't work. So R1, go ahead, log in, enable to get into privileged exec mode. Let's go ahead and ping. And we're pinging PC3, so 192.168.30.3. Notice here, instead of getting the exclamation mark saying it worked, we are getting the U's that are saying unreachable. We have a success rate of 0. So were the pings successful? No. Because they were from a network that was not allowed. Question E. Issue the show access list command again. Note that the command output displays information. So on R3, we're going to minimize this. Go to R3 here. We are going to issue the show access -list 1 command. It shows us that it shows us access list 1. It's a standard IP access control list. It gives us our access control entries. We're allowing one network, we're allowing another network, and then we have a deny any. But this time, because we've actually used those access control lists, we can see that there's been 8 matches. I sent out several pings, and when it got to that access control list, so when it got right here, this access control list filtering traffic, 8 times it matched and it was permitted through. The next one from the .20 network, 4 times it matched and it was permitted through. Down here on the deny any, 9 times it matched. So 9 times traffic made it past this first permit statement, made it past the second permit, and it was denied. Step 2, configure a named ACL. We're going to create a named ACL that conforms to the following policy. Allow traffic from all hosts on the .40 network. This is the .40 network here. It's the 4th one over. To access all hosts on the .10 network here. So all hosts from this .40 network can access all the hosts on the .10 network. Also, only PCC can access the 10 network. So it's only PCC. It's not all the hosts here on the .30 network. It's just the host, it's just the host of PCC can access the .10 network. The name of this access list should be called branch-office-policy. Following Cisco's recommended best practices, on which router would you place this ACL? And so we're starting traffic over here from either the .40 network or PCC. So this is the source area, and we're destined for the .10 network. We want to place a standard ACL as close as we can to the destination. That means it would go here on R1. We have R1 here. On which interface would you place this access control list? So on R1 here, where would you place this? Well, if we'd place it here, it would block all traffic. It would block all traffic coming through here. And there might be legitimate traffic that has to get down to either one of these. So we don't want to block that off right there. If we're going to put it here, it's applying to the wrong network. And so what we have to do is we have to apply it to this network, and that would be this interface right here. Now, to figure out what interface that is, I'm going to click in the white space on this window to make sure this window is activated. Then I'm going to mouse over this green triangle. When I mouse over it, it's going to say that it's the gig 00 interface. So I want to apply to the gig 00 interface. So gig 0/0/0. And then I want to apply it for the traffic that's headed towards that network. So going out of R1, going out of the gig 000 interface. So we want to put it on gig 000 and apply it to outbound traffic. Okay, let's go ahead and create that ACL. So on R1 right here, ACLs are created in global configuration mode. Go ahead and type config T. And now configuring and named ACL is slightly different than a numbered ACL. We have to set up that named ACL. And how we do that is we start off with IP because it's part of the IP suite. Then the keyword of access list because we're creating an access list. But now we have to tell it, is this a standard or extended? Right now we're just looking at a standard one that examines the source IP address. And so we put in the word standard. And then we put the name. In our instructions, we're told to call it branch-office-policy with dashes in between the words. All the letters are capital. Reason the letters are all capital, it helps you identify when you look through all your statistics and a running config, it helps you identify the names of those access control list entries. You don't have to do it, but in this packet tracer lab, it needs to be exactly what they're calling it. And it's case sensitive, so you need to have everything capitalized. You need to have it spelled exactly right with the dashes in between the words. If you do not do that, you're not going to get credit for doing that. And so now let's go ahead and type our name in there. So all capital letters, BRANCH dash OFFICE office dash POLICY. And I'm going to make sure I spelt it correctly. Branch-office policy. Branch-office-policy. That looks good. Now when I hit enter, notice my command prompt changes. My command prompt went from global configuration where I just said config, and now it's saying, well, yes, we're configuring, but we are doing a standard named access control list. It says NACL at the end, named access control list. So we're configuring a standard named access control list. Now we can go ahead and put our permit statements in here. So we go in, do a permit. Technically, you could do them in either way because we're allowing PCC as the host and we're doing the network. But I know here in Packet Tracer, the order matters. So do it like the instructions say. Here we're going to do a permit, and now we're allowing PCC through. Now, you could do 192.168.30.3 and then put a quad 0 in there saying we're going to match all those bits. So it has to be that IP address. It's not a network address. It's not something else. We have to match that exact 32 bits of that IP address. Putting in a quad 0, not overly difficult, but there is even a shortcut way. And so what we could do is put the word permit and then put the word host. And that just means that we're going to match that single IP address and then put the IP address in there. So 192.168.30.3. That's our first permit statement. Our next one is permit. And then that was the .40 network. So 192.168. Whoops. Starting over 192.168.40.0, because we're putting in a network address that ends in a 0. And then our wildcard mask. Once again, that wildcard mask was 0.0.0.255, which is equivalent in the subnet mask of 3255.0. So that permits anything from the .40 network. It didn't say anything about the explicit deny any, so we don't have to type that in. So let's go ahead and check and see what that is. But let's go ahead and look here. We got a question. Look at the first ACE in the access list. What's another way to write it? And that's what I talked about here, was instead of putting the keyword host, we could put in the IP address followed by quad zeros. We put the IP address in there followed by quad zeros. So it would be a permit and then the IP address. So you got to remember, it's in a different order. You put the word host first, and that command would be permit, then the IP address 192.168.30.3, followed by quad zeros, meaning we are going to match all 32 of those bits. So we're going to match that full IP address. Now that we created that ACL, we have to apply to the interface in a direction. Here back in the R1 window, we're in that standard named ACL configuration. Type in exit once, takes us to global configuration mode. Now we can go into that interface. Remember, we are setting it on the gig 00 interface, so we can go ahead and type interface G000. Then we can go and apply that interface. So we start off IP access group, because it's a group of access control entries, and then we either put the name or the number. Here we're dealing with that named access control list, and once again, make sure you type it exactly. And here in the operating system, it does need to meet or match exactly what you typed in right here. So it does need to match this exactly. Let's go ahead and type that in. All capital letters, BRANCH dash OFFICE dash POLICY. And then what direction? We are applying it to the outbound traffic on that gig 000 interface. So out. It applies that access control list there. Is there any difference between this ACL on R1 and the ACL on R3? Well, the first one is one's named, one's numbered. One is a named ACL and one is a numbered ACL. One is blocking a specific host and the other ones are blocking networks. One is, sorry, not blocking, but allowing. One is allowing a specific host. And then the other difference is the one on R3 had that explicit deny. And so R3 has an explicit deny statement. And once again, with that explicit deny, when you look at the statistics for how your access controllers are doing and what each of those entries are doing, how many matches they have, it will actually give you a number. Where if you just use the implicit one where you don't touch it, you're not going to know how many times there was something that was denied at the end. On R1, issue the show IP interface G00 command to verify the ACL is configured correctly. So here's our configuration for R1. Exit once takes us out to global configuration mode. Exit twice to privilege executive mode. Now we can go ahead and enter show IP interface and then gig 000. Gives us our information. Verify we're on gig 00. Status is we're up and up. We have an IP address, and then down a couple lines, we have outbound access list is branch office policy. So we're applying it to all traffic going out. The branch office policy. And then the inbound access list is not set. So any traffic coming in, there's no access list. Test the ACL. From the command prompt on C, ping the IP of A. So from C, ping A. Here in my command prompt. And we're on the command prompt on C. We're going to ping A. So that was 192.168.10.3. And that should be allowed because we are allowing in the access control list the PCC host IP address to go through there. That was in that access control list. Yes, were they successful? Yes, they were. Test the ACL to ensure that only PCC is allowed access to the 10 network. To do so, we have to use what we call an extended ping. And what we're going to do here is on R3, we're going to make the ping, because normally in R3, when we ping, it takes the interface that's on the path to that, and that gives that network address. So it would, because it would show up, it was coming from this network here, it would be denied here. But we want to verify here that traffic from this network that's not PCC won't get blocked. So we have to use this IP address. And what we can do is we can formulate a ping command on R3 here. We can formulate a ping command here on R3 to make it look like it's coming from this interface, the default gateway for the .30 network. So we can formulate that. Now how we do that is we can go in here, type in enable to get into privileged exec mode, and then we can type ping. Normally we type an IP address, but because we want to do some configuration ourselves, we're going to go ahead and hit enter. At this point in time, it's going to say what protocol we're using. We're using IP. We're going to take default, hit enter. What's the target IP address? That's the IP address of PCA, which is 192.168.10.3. Repeat account, we want it to ping 5 times. We'll just take the default. Datagram size, take the default. Timeout in seconds, 2 seconds. We'll take the default. Then this is where we create this extended ping. Do we want to use the extended commands? Yes, because we want to make it appear that it's coming from a different network interface than what it would normally use. So the source address or interface. The source address is this IP address, the default gateway, the IP address that's connected to R3. And so that would be 192.168, and this is the .30 network, and our default gateway is a .1. So that's the IP address we wanted to appear that ping is coming from, 192.168, and that was on the .30 network with the .1 for our default gateway on the .30 network. We wanted to appear it's coming from there. Now type of service, take the default, just hit enter again, all the way through until we are done. And notice, we have got the U. The U in the Cisco iOS for ping stands for destination unreachable. U stands for unreachable. So that traffic appears to come from the .30 network, but not PCC. The access control list, we're only allowing PCC through here and the .40 network, and everything else we're blocking. So traffic from the .30 network that's not PCC will get blocked, and that's what we had happen right here with our 5 U's. Were the pings successful? No, they were not. Test the ACL to see if it allows traffic from 192.168.40.0 network to the .10 network. PCD to PCA is what we're doing. Now that should work because that ACL, we're allowing the .40 network through there. So I'm going to click on PCD, and then we're going to go ahead and ping PCA 192.168.10.3. That goes through our ACL. So that is working. Our answer is yes. Very successful. On to part 3, we're going to modify a standard ACL. There are times on your network when there's a change. You have an addition, or somebody moves, or you did some reorganization, and you need to change those ACLs around. Now, we have to modify them. And so what we're going to do is we're going to change one of the ACLs that we just configured, and we're going to match the new policies. What we're going to do here is attempt to ping the server from PCA. So PCA here, we're going to go ahead and attempt to ping the IP address of the server. So ping 209.165.200.254. Now it's failing. Why is it failing? Well, the echo request is going from PCA through our network, through R1 to the edge router, through the internet to the server. The server gets the echo request, sends back an echo reply, goes through the internet to our edge router, then it comes down to R1. R1 has that filter, that ACL on there that says only traffic from PCC or the .40 network is allowed through there. And so that echo reply came from the web server here, not part of what we're allowing through, so it's going to block it. So the echo replies never make it back. Management has decided that traffic is returning from the 209.165.200.224/27 network should be allowed full access. So we want that ping to actually work also. So we need to add that permit in there. Management also wants ACLs on the routers to follow consistent rules. We need to put that explicit deny any in there. So we have to modify the branch office policy named ACL. Now there's 2 ways we can do it. We can completely delete it and recreate it. So that's one option. The other method, option 2, is to go in and put your commands in there. And so that's what we're going to use. We're going to use option 2 for this activity. First thing we're going to do from R1, we're going to see what our access lists look like. So on R1 here, I'm going to go ahead and issue the show access-list command. I'm going to list out all of our access control lists. And so we have a standard IP access list that's named branch office policy. We're permitting hosts from the .30.3, that's PC4 network. And then we're permitting traffic from the .40 network. Any host on the .40 network we're permitting through there. Notice the first one has a sequence number of 10. That's permitting PCC through. And then sequence number of 20 is allowing any traffic from the .40 network. What we have to do is now add in a sequence 30 that permits traffic from our server, and then we have to put our explicit deny. And how we do this is we actually go in like we were configuring our named access list. First, we got to get into global configuration mode, config T, and then it was IP access -list. Then we have to say, is it a standard or extended? We're still on our standard, so it needs to match exactly what you entered in before. Standard. There we go. Now I spelled standard right. And then the name of it. Once again, it has to match. If it doesn't match, you're going to create a whole new access list. So make sure it matches exactly. All capital letters, dashes in between them. So all capitals, BRANCH OFFICE POLICY. That will be the access we're in. Once again, notice our prompt changes. We are now doing a standard named access control list. And we want to make sure it goes into sequence 30 to allow the server through. And so we can start off by saying, this is the sequence number. This is 30. Then we're going to permit, and we need to figure out what the network address is up here of this. If we go through and look at that, we can get that information from up here, 209.165.200.224. If we actually turn this into binary, the .224, it ends in 0. So this is the network address. And then our subnet mask is a /27. 27 ones followed by 5 zeros. Wildcard mask is the inverse of that. So 27 ones in the subnet mask turns into 27 zeros, and then 5 zeros at the end in the subnet mask turn into 5 ones in the wildcard mask. Break it up into octets. We got 8 zeros, 8 zeros, 8 zeros for the first 3 octets, and then for that last octet we have 3 zeros and 5 ones. Convert that into decimal. You convert that into decimal, it turns into a .31. So our wildcard mask is 0.0.0.31. So back to our permit statement, we put our address in there, which was again 209.165.200.224, and then our wildcard mask of 0.0.0.31. That adds our statement in there. A sequence number 30 to permit traffic from that network. And then we want to put that explicit deny in there at sequence 40. So we start off with 40, deny any, and that's our explicit deny. Those are the 2 things we needed to add in there. Let's go ahead and verify our ACL. Type out exit once to get out of configuring our standard named ACL. Type exit a second time to get into privilege exec mode. From here, we can go ahead and issue the show access-list command. It'll list out our access control list. Once again, I typed my command in wrong, and Cisco was kind enough to tell me that I had an invalid input error at the marker, little pointer up. Here's that little pointer up. So right in this area, I have a problem, and I spelled access wrong. To fix it, I hit the up arrow. Now I'll left arrow over, make the correction, and hit enter, and it lists out my access control list. We have a standard access control list on the IP protocol named here, and then we have our access control entries. Sequence 10, we're permitting from the .30 network. Sequence 20, we're permitting from the sequence 10, we're permitting PCC, just the host of that. Sequence 20, we're permitting traffic from the .40 network. Sequence 30, we're permitting traffic from the server network. And sequence 40 is our explicit deny. You have to apply the branch office policy to the G01 interface on R1. So do we have to apply it there? No, we don't have to, because it was applied to the interface and we never took it off of the interface, so it's still there. So no, we don't have to apply it. So no. 2, test the ACL to see if it allows traffic from the server network to return to the .10 network. So what we're going to do is ping PCA to the server. Now PCA is going to send traffic up here to the server, and then the server is going to send back the reply, and then hopefully it'll make it through there, because now we're allowing that traffic to make it through. So on PCA, we're going to go ahead and ping server address of 209.165.200.254. And it's not working. Why isn't it working? If you look closely, instead of typing a 209.165, I typed 209.168. I'm going to let it time out here. I'm going to type it in again. Ping 209.165. Did it again. 209.165.200.254. And there, pings are going all the way to the server and returning. We got 4 successful round trips. It is working. On to our reflection questions. As you can see, standard ACLs are very powerful and work quite well. Why would you ever have the need for using an extended ACL? Standard ACLs filter on source IP address only. So we put them as close as we can to the destination to allow that traffic to go the other places on the network. Extended ACLs, they filter on source, destination IP addresses. They filter on TCP versus UDP. They filter on layer 4 port numbers. Well, they filter on a lot more different variables to give you that granular control. Why would you ever need them? You may have a particular reason on your network why you want to block port 21, why you might want to block port 80. You might want to block telnet traffic. You just don't want telnet traffic on your network, but you want to allow other traffic like SSH and web traffic on your network. So you may want to be a little bit more granular in your control. Why would we ever want to do this? We want a finer control of the traffic on our network. Second question. More typing is typically required when using a named ACL as opposed to a numbered. Why would you choose a named ACL over a numbered? Because you have to type in the name, they're longer in how you enter in that information. Usually involves a little bit more typing. Well, there's two reasons. When you use the named one, you can go through and modify that ACL using sequence numbers. So we can modify using sequence numbers. And the other reason is you could give it a descriptive name, meaning block telnet traffic could be your ACL. And that would be a little bit easier to remember what that ACL does versus ACL number 12. What does ACL number 12 do? You can't tell necessarily by the name. Maybe you'll memorize it, maybe you won't, but if you gave it a name, it could be descriptive. So names are more descriptive. That was Packet Tracer Lab 5.2.7, configure and modify standard IPv4 access control lists. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.